You ever wonder how a large language model goes from being this raw, super knowledgeable brain to a helpful assistant you can actually have a conversation with? Well, today, we're going to pull back the curtain on that whole process. Think of it like a journey, from a brilliant but clumsy apprentice to a skilled and reliable master. Let's dive in and see how it's all done.
So this is basically ground zero. On the left, you've got our apprentice, the base model. It knows a ton of stuff, for sure, but its only real goal is to predict the next word. So you ask it a simple question, and it might predict a question mark first, just because it's seen that pattern online. It's awkward. But on the right, that's the master. It gets that you're asking a question and just gives you the straight answer. Our job is to close that gap. And the way we build that bridge is through something called post-training. This is the mentorship phase. We're not trying to cram more facts into its head. Instead, this is all about alignment, teaching it how to behave. We want it to follow instructions and live by 3 simple rules. Be helpful, be honest, and be harmless. This is what turns a text-predicting machine into a partner you can actually trust. So where does this mentorship even start? Well, the first stage is all about hitting the books. We call this Supervised Fine-tuning, or SFT for short. You can think of it as the apprentice's book learning phase. SFT is pretty much what it sounds like. We create this custom-made textbook for the model, filled with thousands upon thousands of pristine examples. Each one has an instruction, a prompt, and then the absolute perfect response. By studying these pairs, the model starts to learn the style, the format, and the tone of what a great assistant sounds like. And I gotta emphasize that word, quality. As this quote from the Gemini team points out, the quality of that textbook is everything. See, for pre-training, you can just throw the whole internet at the model. But for SFT, the datasets are smaller and have to be meticulously curated. It is the classic case of garbage in, garbage out. And that's because, well, a flawed textbook is going to create a flawed apprentice. It's that simple. If your examples have wrong answers, or they only cover a tiny range of topics, or they have these weird gaps in logic, the model is going to learn all those bad habits. This is exactly why research teams spend so much time and energy just cleaning up this data. It is the foundation for everything else. Okay, so once our apprentice has studied the textbook, it's time to get some hands-on experience. This next phase uses a technique called reinforcement learning. You can think of it as giving the model on-the-job feedback to help it learn and grow. Now, this brings up a really interesting challenge. For something like a math problem, there's one right answer. Easy. But what about creative tasks, like writing a story or summarizing a meeting? There could be tons of different good answers. So how do you teach a model to develop good judgment in these really subjective situations? The answer is by giving it different kinds of feedback, or what we call rewards. For those subjective tasks, we often use RLHF, reinforcement learning from human feedback, where a human just looks at 2 responses and picks the better one. Simple as that. But for things with clear right or wrong answers, like coding, we can use verifiable rewards, where a program just runs the code to see if it works. Each type of reward is like a different tool for shaping the model's judgment. And here's a peek at how that feedback loop actually works in practice. With an algorithm like GRPO, the process is really powerful. For any prompt, the model spits out a few different answers. Each answer gets a score from our reward system. Then the algorithm just nudges the model to be a little more like the answers that scored above average. You repeat that process millions of times, and the model's judgment gets better and better and better. After all that book learning and all that feedback, it is finally time for the final exam. We have to evaluate the model and see if our apprentice is really ready to graduate and become a master. And these exams come in 2 main flavors. On the left, you have ground truth evaluations. Think of these like multiple choice tests. They're objective, super fast, and perfect for checking things like math and code. On the right, you have LLM-judge evaluations. This is more like an essay exam, where we use another powerful AI to act as the grader. It's really scalable and great for capturing those subjective qualities, like how helpful or clear an answer is. But here's the thing, automated tests can only tell you so much. The absolute gold standard is, and always will be, human evaluation. At the end of the day, the only way to know if an AI assistant is truly helpful is to have actual humans interact with it and judge its answers. That's the real test. And to make that human judgment even more reliable, we can borrow a really clever system from the world of chess, the ELO rating. Basically, you have humans compare 2 model responses head-to-head, over and over again. By seeing who wins these matchups, you can generate a really robust ranking. A higher ELO score just means humans consistently like that model's answers better. It's a fantastic way to measure performance.
So let's just take a step back and look at the whole journey. Through this really intensive process of learning, feedback, and evaluation, the model has been completely transformed. And here it is, the entire transformation laid out. We started with a raw model that could only predict the next word. Then, through supervised fine-tuning, it learned to follow instructions from a textbook. After that, reinforcement learning gave it a mentor to refine its judgment with constant feedback. And the result? A capable, instruction-tuned assistant that actually understands and responds to what we want.
So we've seen how the sausage gets made, but this whole process leaves us with a final and pretty fascinating question. Since these AI assistants are literally trained to align with human preferences, the feedback we give them is actively shaping who they become. It really makes you wonder, what are we collectively teaching them about what it means to be helpful? What values are we encoding into our future AI partners? It's definitely something to think about.